Have you noticed that hardware has gotten much better since the 90s and early 2000s? Yet, somehow software didn't get any better. Actually, if anything, it got worse. Like, there are exceptions, of course, where graphical software, clear pictures like this, got much better because of the hardware capabilities. But speaking of normal, applications that we build like backend engineering, database engineering, we given all this juice to the software, but software is getting actually worse. If you start these apps, it takes like, I know I'm not exaggerating, but 5 to 10 seconds for them just to start on my latest and greatest M4 Pro Max, right? And then don't let me start it in Windows because at work we use Windows. Same exact thing. Outlook, Teams, all these apps, a lot of things got bloated for some reason. What is going on? And if I were to guess, it is a combination of abstractions. We got used to trying to make the code easy, which I made a video about, because I don't want to write all of this stuff. Because code, the nature of code is complex, because you're interfacing with multiple things, you're talking to this hardware and this hardware, and there is like a certain interface to talk to this hardware, and you can optimize those. But there are certain class of developers who likes things to be simple, so they, as we used to say, like they take the carpet, all the dirt, they shove it under the carpet and then hope everything is clean, right? That's how my son cleans his room. He takes all the toys and he shove it in the closet, and then he closes the closet and they says, hey, the room is clean now. Is it really? So the idea of adding an API to simplify things, adding a framework, adding a library, adding whatever you want to call it, the goal of all of these is to make the code simple. That is what we try to do. We try to make things simple, but guess what? Nothing is really simple. So you're just exposing one line of code. Behind the scene, it's doing all of these operations and you don't know about them. The only thing you did is you just literally closed your eyes and, oh, I hope everything just works. That's what happens. You just created a simple call, but the deep thing is still happening. The chattiness still happening. If anything, that simple call will cause bad practices, because now it looks simple. That means it's okay to put it inside a loop. It's okay to call it multiple times. It's okay to call it every time I start up the app. It's cheap because it looks simple, right? It gives you that illusion of simplicity, but it's not really simple. There is a lot going on behind the scenes. And that pattern evolved and evolved and evolved. And that's why when new hardware comes into the picture, we use the existing software that we built on top of it, and the hardware is rarely taken advantage of. Or if anything, the software is so badly written that we are saturating the hardware and making no use out of it because we're so inefficient. By being inefficient, we have hardware that is not being used optimally. So what's the solution? We keep making the hardware better. We never fix the software because, God forbid, let's not touch this. I'm not saying that's all what's going on. There are people who are taking good look at software that's being built. An example that I can think of is DirectX, right? And Vulkan, which gives you the ability to interface with the hardware, but all the graphics in a specific thing. But that kind of takes a fundamental look and rewrites it so it's less chatty, natively written. And there are people who are doing that. These are the good developers who look at things. But still, it's a very hard job if you have decades and decades of software built on top software, built on top of frameworks, built on top of games, and then you build everything on top of this, and then it's a sticky thing. You cannot get rid of this thing. So people cut corners. So let's build a compatible layer with this thing. But if you build a compatible layer, then you're still cutting corners. So you're not fully optimizing. And the only way to optimize is to rewrite the entire thing from scratch, which is a gigantic task. Nobody's gonna do it. So we end up giving up at the result. But yeah, software is, and I'm including all the software. This includes the Linux kernel. This includes all the other abstractions. There are a lot of things. The Linux kernel to this day is being optimized. People who are like sharp engineers are taking a closer look and it says there are inefficiencies in every software out there. Don't look at the Linux kernel as an exception. No, it's maybe one of the worst because it's being used and then included in all these included in all of these distros, and it's included in everywhere. So there is inefficiency in everywhere, and it takes someone to look closely at what we are interfacing with and then how to make it better. The problem is, if we're trying to make things better, the best way is to fix the hardware. And then you built one software for this. And Apple is the only one that is in that boat. They build their own hardware and they optimize it to their need. And still their software is crap, right? There is a lot that can be done to take advantage of that. And I think we're not even close to build efficient software. And another reason is because as the hardware gets better and better, we get lazy and we build software that is inefficient because, well, it's good enough on this top model hardware, especially that most developers write their software on the latest laptops and mainframes. So then when they ship the software, it looks good, although there are all sorts of memory leaks that there's not discovered, all sorts of inefficiency that is masked by the good hardware. But once you ship it on a lower budget hardware, it tanks. And the solution is not to fix the software because, hey, it works on this good hardware. So what is the solution? Spend more money, upgrade your hardware. Never fix the software. That is the mentality that we have. Never ever fix the software. Always upgrade the hardware. And that is the problem that we have. If we keep that mentality in place, we'll never build good software because good hardware is a crutch for us. And that's just sad, to be honest. Again, there are folks who take pride of building good software. And I can think of examples, Curl, Daniel. This guy looks at every single byte they allocate. HA Proxy is another company that I'm proud. I'm very proud of the team there, to be honest. There are others as well, but they take those guys, the HA Proxy folks, they have a machine that they test their product on that has only 256 megabyte of RAM with one core. They only certify if it passed on that machine, because that machine, that low hardware machine, will flush or flush out. Is it flush? I always confuse these two words together. Will flush out any bugs or any performance regression, because hey, whatever you did here slowed down significantly. Some companies will say, well, this is just old hardware. Do you really want me to rewrite the whole software and because it will delay the project, it will and that's the thing, right? We have always on a timeline, and I understand business, I understand we have deadlines, but I'm just telling you the reason. The reason is this. That's the main reason. Okay, now because we want to ship software fast, and because we want to ship software fast, we cut corners, and if we cut corners, then we'll never ever optimize software. And you might say, who cares? But if that's the mentality that we're following, who cares, then we cannot take pride of being engineers, I think. So guys, keep your skills sharp. If you ever want to polish your skills, your fundamental skills, check out my training courses. I have fundamental operating system, networking, backend, and databases fundamentals. It will help you brush all these courses. Check out the content there. And stay curious, guys. Stay safe out there. Never get your sword dull. See you next time.